Okay, we're going to finish up the non-calculator section of the AP Calculus B final with numbers 26, 27, and 28 on this video. So let's take a look at question 26. Right, 26 brings us this incredibly fun volume, and we're going to read through this really carefully because I know that oftentimes if you don't read this correctly, you're definitely going to do the wrong thing here. So let's highlight a few things here. We're supposed to find the volume of a solid described below. The base of the solid, okay, this is a base of the solid type question, is a disk where x squared plus y squared is less than or equal to 9. Okay, so that is definitely a circle. X squared plus y squared equals 9. The radius of this circle is 3. And so we're going to build cross sections perpendicular to the x-axis. Okay, so that's going to be this red line right over here. Okay, this is going to be the bottom of that cross section right along this red line right here, which I'm highlighting. Okay, that's going to be the bottom of our cross section. So it's going to be an isosceles right triangle that has one leg on the disk. So here's our isosceles right triangle, and it's important for us to know that whenever we're doing these volumes, if this is the base, we're not going to see this triangle on that base. Okay, this triangle is going to be in 3 dimensions coming away from the base toward, the viewer of this. So it's not actually on this at all. The base in question, that red line that we're seeing there, that is this red line right here. Okay, and I make a habit of calling that red line L. Whatever it is that's going along from top curve to bottom curve, I call that L. And we can get an equation for L because it is the distance from the y coordinate up here at the top to the bottom. So L is going to be the y coordinate up here minus the y coordinate up here. So in other words, L is going to be equal to that 9 minus x squared from the top curve minus negative square root of 9 minus x squared, which would be the curve on the bottom. Or to put it another way, L is equal to 2 times the square root of 9 minus x squared. Now, since this is an isosceles right triangle with the leg along the base, we also know that this vertical height here is also equal to L. And that tells us the area formula. So the area formula is equal to 1/2 base times height. And since the base and the height are both L, then the area is equal to 1/2 of L squared. Well, we also have a formula for L. So the area is going to equal to 1/2 of the L formula squared. The L formula was 2 square root of 9 minus x squared. Let's put that in here. And our final simplification, and don't mess this up, is going to be to square everything. We've got 2 times 2 times 1/2, and that's just going to be equal to 2. So the area formula is going to be equal to 2 multiplied by 9 minus x squared. Maybe that's easier as 18 minus 2x squared. So to find the volume, the volume is going to be, for every problem that we've done this semester, the volume is always equal to the integral of the area formula. And since we have our area formula, we can just substitute that in there now. So then our volume is equal to our area formula, which is 18 minus 2x squared. And then we can talk about the lowest value of x on this curve is x equals -3 on the left and x equals 3 on the far right. And that really does it for us. Let's highlight those. X equals -3, x equals 3. Now I'm always looking to make the work easier. So in order to make the work easier, I notice that the left half and the right half of my shape are going to be the same. So I'm going to multiply by 2 and cut this from, instead of -3 to 3, we're going to go to 0 to 3. So that's going to make my substitution and all of that business a whole lot easier. Okay. Now let's do our integration. Okay. Let's see, this right over here, we're going to substitute with our antiderivative. And our antiderivative is going to go from 0 to 3. So what is our antiderivative? Well, the antiderivative of 18 is 18x minus the antiderivative of x squared is 1/3 x to the 3rd power. We can simplify that, of course. And I think what I'm going to do is I'm going to distribute this 2 into the volume formula just to make my, make my calculation easier. So let's distribute that 2. That makes this a 36, and that makes this a 4. But of course, we can put that 4 up here, and yeah, that looks really good now. Okay, let's substitute. Okay. Okay, first we'll substitute a 3. We'll change this x into a 3. And we'll change this x into a 3 as well. Great, and then we'll change, in the second one, we'll change this x into a 0. And then we'll change this x into a 0. All right. Now that's good for us. We did this on purpose because we wanted to substitute a 0. It's a whole lot easier to evaluate a 0 than a -3. All right. Clearly, this whole second half here is going to evaluate to 0, so I can just get rid of that. 3 times 36 is 3 times 30, which is 90. And plus 3 times 6, which is 18. 90 plus 18 is 108. This is 108. 3 cubed divided by 3 is the same thing as 3 squared. So 3 squared is 9. So this is 4 times 9. Uh, 4 times 9 is 36. Let's see, 108 minus 36 is, that looks like a 72 to me. And yeah, I think that does it. 72 here is the volume of this solid. Now, it's not necessary for us to draw our solid at any point. All we need to know is the distance from the top curve to the bottom curve, a visual of what the cross sections look like, and then the area formula for those cross sections. Remember, you're not going to see those cross sections anywhere in this shape. All right, moving on to question 27. 27 is, let's see, a solid of rotation. Oh yes, solid of rotation. So we're going to revolve the region in the first quadrant bound by the curves x equals 1 and y equals 4 minus x squared. We're going to revolve that around the x-axis. So we're only in the first quadrant, so we're going to only take a look. Yeah, let's graph this. 4 minus x squared is a parabola that opens downward with a vertex at 0, 4. Let's see if we can produce one of those neatly. So the region in the first quadrant bound by these curves is going to be this piece right over here, shaded in. And we know we want to revolve that region around the x-axis. So my axis of rotation is going to be, let's see, it's going to be, let's draw our line. This is going to be my axis of rotation right here. Okay, let's label that axis of rotation, and let's set about now finding our radius. So the radius is always going to be the distance from the axis of rotation to the outermost curve, or the innermost curve, but there's no innermost curve here. The other thing I want to notice is that the axis of rotation is a boundary curve, so this is going to be a disk method. Okay, so let's draw our lines. Let's use green here for our, let's use green for our radius. So our radius is going to, and I'm just going to pick anywhere in the middle of this shape, doesn't matter where, and I'm going to go from the axis of rotation up to the curve, and let's fit this a little better. Okay, so that's our radius right there. I'm going to use big R, and the radius is going to be the difference between the y-coordinate at the top and the y-coordinate at the bottom. So up over here we have the y-coordinate is 4 minus x squared. If you're reading that's literally what it says right here. The y-coordinate is the same thing as 4 minus x squared. Okay, so that's a y-coordinate up here. And then I want to subtract from that the y-coordinate down over here. And that y-coordinate down there is just 0. So let's do a little bit of color coding here. And I hope that's clear where those values came from. We can simplify that, of course, into the radius equals 4 minus x squared. Now we know it's a rotation, so the area formulas are going to be the area for a circle. So that means the area formula, and let's make that a of x, that's going to be equal to pi r squared, which of course is equal to pi, and then my radius is 4 minus x squared. That's probably a good idea to simplify that now before we start looking at an integral. So that's just pi multiplied by expanding. 4 times 4 is 16. 4 times negative x squared is negative 4, plus another negative 4 is negative 8x squared. And then negative x squared times negative x squared is x to the 4th power. So that is my expansion and my area formula. Now all I need to do is integrate this from the lowest value of x to the greatest value of x. So we got the volume is going to be equal to the integral from a to b of the area formula dx. Oh yeah, that's looking very nice right now. Everything is making sense. We're going to take that, and now we're going to substitute our area formula, which we just found was pi multiplied by the quantity 16 minus 8x squared plus x to the 4th power. And then we're going to go from the lowest value of x, which is over here, x equals 0, to the greatest value of x, which is right over here, at x equals 1. Okay, got our volume formula. Now we're gonna integrate. We could take that pi on the outside, take that pi, bring it outside the integral, and get rid of it from the inside. And now we just have to, let's integrate each piece. Okay, the antiderivative of 16 is 16x. The antiderivative of x squared is 1/3 x to the 3rd power. And then the antiderivative of x to the 4th power is 1/5 x to the 5th power. And then we're going to go from 0 to 1 again. All right, let's substitute and evaluate. Actually, let's distribute that pi. We're going to put pi in each one of these. Let's see if that makes things easier. 8 times pi, and this is going to be pi over 5. Okay. All right, we're set to substitute. This first is going to be a 1 over here. Well, we can actually make this an 8 pi up here, and then get rid of the 8 pi down here. I suppose we don't need the parentheses anymore, so we can do that. And we can turn that x into a 1. And now this x over here, that's also going to be a 1. These x's over here, they're going to be a 0. I'm not going to make too much of a fuss on this one, since I know the 0 times 0 is just going to be 0. Great. All right, here's our substitution. And let's simplify now. Okay, over here, all of this is 0. So I'm just going to get rid of it. We're multiplying all of these by 1. So 16 pi times 1 is 16 pi. 8 pi over 3 times 1 is 8 pi over 3. Pi over 5 times 1 is just pi over 5. Okay, and I think we're going to, let's see, how can we do this real quickly? Okay, how about if we take these last two terms and we put them on a common denominator and see what falls out. So our common denominator is going to be 15. This first one I'm going to need to multiply by 5, so 5 times 8 is 40. This one I'm going to have to multiply by 3, so 3 times pi is 3 pi. And I don't see a way around it, so we'll have to put this one over 15 also. So we're going to have to multiply this numerator also by 15. Let's see. That's the same thing as 10 plus 5. 16 times 10 is 160. 16 times 5 is 80. And let's see, 80 plus 240 over here. 240. So if you've got 240 minus 40 is 200. 200 plus 3 is 203. That's 203 pi, the whole thing over 15. Great. And that brings us to our last problem. Oh my gosh, we're at the last problem. I can't believe it. We're going to find the volume of the solid formed by revolving another region. This time it's bound by y equals 0, which is the x-axis. X equals pi over 2, which is the vertical line. And then the curve y equals sine x. Okay, we're going to have to graph that. Sine x is kind of goes up like that. So let's take a look at that. Now in the previous example, I was a little bit, how do I say this, off put because I had a my region was in red. So this time I've made it in purple. So here's my y equals sine x graph. This is my axis of rotation up here. Axis of rotation. Right up over here. And we're revolving this line about that red line, or this region about that region. So I'm going to notice that the axis of rotation is not a boundary curve for that region. So this means I'm going to have a washer method. Now for the washer method, we're going to look for two radii, an outer radius and an inner radius. And I think we're going to start with the inner radius. So the inner radius, let's pick a color, let's pick blue. And my inner radius is going to be the distance between the axis of rotation and the most inside curve. So that's going to be this one right here. Now at the top of that curve, we've got y equals 0, and at the bottom of the curve, the y coordinate is sine x. So my small radius is going to be 0 minus sine x, which is the same thing as negative sine of x. Okay, so that takes care of my little radius. The larger of the two radii is going to go from, once again, it's going to start at the axis of rotation, but this time we're going to go to the furthest part of the boundary. So that goes all the way down to here. Now, as I was doing this, I did realize that I'm making a mistake over here. The y-coordinate up here is not 0. The y-coordinate up there is 1. So this should be a 1 minus sine x for my smaller radius. Now my larger radius then is going to be, well, that's a little easier for us. Our larger radius is going to be the y-coordinate on top, which in green you can see that that's 1, minus the y-coordinate at the bottom, which is always going to be y equals 0, which of course means that my large radius is always going to equal 1. All right, let's square our radius, or radii. Our large radius squared, that's going to equal 1. And our smaller radius squared, well, that's going to be equal to quantity of 1 minus sine x. This whole thing is squared. And like before, I think it's probably a good idea to expand that. So let's expand that. 1 squared is 1. 1 times negative sine x is negative sine x. And so there are 2 of them, so that it's minus 2 sine x. And then sine x squared is, well, that's sine squared x. And that's going to be plus a sine squared x. And that is our smaller radius squared. We are going to need to integrate, so this is actually a more difficult thing than we were being led to believe. So we're going to substitute that sine squared x with our power reducing formula. So then using this formula where sine squared x is equal to 1/2 1 plus cosine of 2x, we're going to replace this sine x with that 1/2 1 plus cosine 2x. We're going to simplify that again. We can distribute this 1/2. So this will just be 1/2 times 1 is 1/2. So right over here, we get a 1/2. And then we'll distribute that over here as well. So we get another 1/2 right there. And that gets rid of, cancels that out. Of course, now we don't need to have this in parentheses. So we'll take this out of the parentheses. And there is one more thing we can do. We can take this 1/2 and combine it with this 1 over here. And that gives me a 3/2. Right, so here's my radius squared. Okay, that is all the simplification we're going to need to do. And now it's time to use that washer method. So the washer method is going to be that the volume is going to be equal to the integral from a to b of pi big radius squared minus the little radius squared. Let's take this formula and substitute my big radius and my little radius. See what we get. Let's see, the big radius squared was 1. So let's substitute that with a 1. And then the little radius squared, let's substitute that with this one right here. That's 3/2. That's my little radius squared. The lower limit here is going to be here at x equals 0, and the upper limit here is going to be at x equals pi halves. We're going to go from 0 to pi halves. There we go. Give ourselves a little room. And before we integrate, let's simplify. Always worth our time to simplify. So we can, let's see, that gives me let's change this to a plus at the price of changing all of these over here. So that's going to change to a plus. That's going to change this guy to a plus. And now we can just take this and take that out of the parentheses. Okay, that looks good. Let's see, we can also simplify this. 1 minus 3/2, that's negative 1/2. Okay, and I think we are ready to integrate now. Let's take that. We'll put our pi on the outside. And let's take the integral of each one of these pieces. All right. Antiderivative of -1/2 is -1/2 x. Antiderivative of sine is negative cosine. Antiderivative of cosine 2x is 1/2 sine 2x. And that's going to go from 0 to pi halves. Right, there's my antiderivative. And let's see, we can simplify that a little bit. That'll make it a little easier for us to integrate or to substitute. Let's see, this negative cosine, we can make that a minus, and this a plus, and that just brings this cosine on the outside, so that's just now cosine x. 1/2 times 1/2 is 1/4. And then now we can just take this out. So that's now sine of 2x. All right, that's going to make things easier to substitute. Yeah, let's do that then. Okay, let's substitute. Okay, we have this all built in. We're going to substitute all of these x's now with a pi halves. And then we'll take these x's back here and we'll turn these into zeros. There's our substitution. Then now we're going to evaluate. Okay, let's see. -1/4 over here, sorry. -1/2 times pi over 2, that's negative pi over 4. Okay, cosine of pi over 2 is 0, so we can get rid of that completely. Okay, sine of pi, or 2 times pi is 2 times pi over 2 is pi, so we can change this to a pi. And then sine of pi is, well, that's also 0, so we can just get rid of all of that. And in the back half here, we've got 1/2 of 0. That's 0, so let's get rid of that. Cosine of 0, this is where things can go wrong. Cosine of 0 is 1. And then we've got sine of 2 times 0, which is sine of 0. Sine of 0 is also 0, so we can get rid of that. All right, so I think we've reached a place where I'm going to copy that down and simplify a little bit over here. Let's see, pi times pi over 4, that is pi squared over 4. And then we're going to take this minus, change that into a plus, and we don't need that. So that's what we're getting here. It looks like pi squared over 4 plus pi. And I think I need a negative there. And somehow I missed it too, and I think I just found it over here. This antiderivative of 2 sine x, that's -2 cosine x. So -2 cosine x over here, a 2 over here, a 2 over here. Man, I hate doing this to you. And let's see, this is 2 times 0, so this is actually a -2. 2 times the cosine of 0 over here, that's -2. That's where this -2 comes from. And so that is a 2 pi over there. There we go. Negative pi squared over 4 plus 2 pi. Let's move that 2 pi in front. That looks a lot better. Okay, and that is our multiple choice, not our multiple choice, our no calculator section, multiple choice. And yeah, we'll see you on the next one when we start to look at calculator questions.